Here are some examples of problems about sums. Problem 1. Find the sum of the squares of the first 50 positive integers. The first 50 positive integers range from I equals 1 to 50, and we want to find the sum of the squares of these numbers, so we find the sum of I squared. We already know that there's a formula to solve sums of this form, which is n times n plus 1 times 2n plus 1 over 6. So if we plug in 50 for n, we have 50 times 50 plus 1 times 2 times 50 plus 1 all over 6, which equals 50 times 51 times 101 over 6. If we factor the 2 out of the 50, we have 25, and if we factor the 3 out of the 51, we get 17 times 101, and that gets rid of the 6. And computing this will give us 42,925. Problem 2. Write out all terms of sum I equals 3 to 7 of 4i minus 2 and compute the sum. For this sum, we need to find 4i minus 2, starting with I equals 3, so 4 times 3 minus 2, and all the way up to 7. So plus 4 times 4 minus 2, plus 4 times 5 minus 2, plus 4 times 6 minus 2, and finally plus 4 times 7 minus 2. Now each of these terms are 4 times 3 is 12 minus 2 gives us 10, plus 4 times 4 is 16 minus 2 gives us 14, and 4 times 5 is 20 minus 2 will give us 18. Notice these increase by 4 every time, so we can just continue and get 22 and 26 for the last two terms. Now if we add these up, we have 10 plus 14 plus 26 gives us 40, plus 18 plus 22, which gives us another 40, and these three sum to 90. So that's the final value of the sum. Problem 3. Use induction to show that 1 plus r plus plus r to the n is equal to 1 minus r to the n plus 1 divided by 1 minus r. Note that it's equivalent to show that 1 plus r plus plus r to the n times 1 minus r is equal to 1 minus r to the n plus 1, since we can multiply or divide both sides by 1 minus r, at least for r not equal to 1. To use induction to prove this, first we show the base case. So what if n is equal to 1? In the case that n equals 1, this statement simply says 1 plus r times 1 minus r is equal to 1 minus r squared. If we actually calculate this out, then we get 1 plus r times 1 minus r times 1 minus r squared. These two r's will cancel, and we get 1 minus r squared as desired. Now suppose that we fix some k, n equals k, and we know for sure that 1 plus r plus plus r to the k times 1 minus r is equal to 1 minus r to the k plus 1. We now want to use this to show that this formula holds for k plus 1. So in the case of k plus 1, we have 1 plus r plus plus, I'll just write an extra term here, r to the k plus r to the k plus 1 times 1 minus r. Now we need to show that this is equal to 1 minus r to the k plus 2. So how do we do that? Let's separate this into terms that we can deal with. One term, we can use the distributive property to say 1 plus r plus up to r to the k times 1 minus r, and then we add the other term, which is r to the k plus 1 times 1 minus r. By the inductive assumption, which is the formula that we have for k, we already know the value of the first term. We know that it's 1 minus r to the k plus 1. And for the second term that we have, we can just evaluate it directly. R to the k plus 1 times 1 is r to the k plus 1. Then minus r times r to the k plus 1 is r to the k plus 2. Now, these middle terms, plus and minus r to the k plus 1, are going to cancel, leaving us with 1 minus r to the k plus 2, which is exactly what we wanted. Now, since we've proved that it's true for 1, we can use the inductive assumption to assume it's true for 1, since we already proved it, and then use that to show that it's true for 2. Then we can use the assumption that it's true for 2 to show it's true for 3, etc., which shows that it's true for any value of n. This is how induction works.